All right, everyone. Hope you're doing well. It's a bit of a shout out to my grade 9 math students. This video is going to be a bit of a trial as I do a very quick explanation of chapter 7.3. I meant to do this earlier, but I had my hands tied and all teachers were sort of told to hold off on making anything sort of outside of what the textbook already offers. Stay tuned. There's going to be probably a couple more changes or some announcements to try to get a bit of a routine and a sense of normalcy in our online time together. Okay, so currently, might as well make a little title. This is going to be a recap as a lesson 4. Ooh, I don't want green. 7.3, and that is angle. Wow, this is really poor writing. Relationships in polygons. Ugh. Please excuse my terrible writing. Okay, hopefully the lesson itself will be all right. Again, this is a bit of a test. If my sort of screenwriting isn't good, then maybe I'll just go into paper and pencil and record my hands drawing stuff. Okay, for now, I would like everyone to consider this. It's a bit of a mind's-on. It's a little bit of apply your thinking, and we will, at the very end of this, figure out this equation together. And what is that? The whole point of 7.3 is to come to the point where the sum of interior angles of any polygon is going to be equal to 180 degrees multiplied by n minus 2, where that is equal to, just different color just to make a difference, number of sides of the polygon. Okay, so let's get to it. Food for thought. Here is a triangle. Okay, without me giving any of these angles, okay, any detail about these angles, this angle and that angle and that angle, what does that add up to? Do. This is angle A, angle B, and angle C. Well, we know that, let's do it in black. Angle A plus angle B plus angle C, no matter what those angles might be, are always going to equal 180 degrees. Because of what theorem? Angle sum triangle theorem. Good. And that's it. Okay, now I'm going to extend that. What if I asked you to draw another triangle? You know what? Let's use a different color. Okay. What if instead of a 3-sided shape, I asked you to consider a 4-sided shape? What is the sum of all 4 angles? Well, take a step back. What would be the sum of these 3 angles of this pink triangle? Going once, going twice, it would be 180 degrees. So we have 180 degrees total here and 180 degrees total here, right? Well, go along with me using a different color. If I added this angle and added all of that together and added all of that together and added all of that together, I added 180, the interior angles of the first triangle, and I added 180, the interior angles of a second triangle. The sum of interior angles of the four-sided shape, in other words, a quadrilateral, is 360. Okay then. But what if I go one step further? What if I asked you to continue by turning this into a five-sided shape? And just in case I confuse you, I'm going to draw that. I'm going to go about erasing this line, all of these angles, and all of that. I turn this into a five-sided shape. Then what? What would the sum be? Well, once again, the interior angles for triangle ABC is 180. The interior angles of the bottom triangle is 180, and the interior angles of the top triangle is 180. Long story short, if I were to add this angle, and that angle, which is 180, and this angle, and this angle, and this angle, which is 180, this angle, and this angle, which is 180, I have effectively added the interior angles of the larger five-sided shape. In other words, I just have to add 180 plus 180 plus 180. Sum of interior angles of, in this case, this is a bit of an unusual pentagon. I'm just going to say of five-sided shape is 540. And essentially, every single time we are adding an extra side to the shape, in other words, this is three-sided, this is a four-sided, this is a five-sided, and if I go six-sided, I'm essentially adding 180 degrees every single time. So how does this turn into my formula? How does that turn into my formula? Well, I'm going to set it up in a way that you might, I guess, recognize. A chart. Number of sides and sum of angles. Number of sides, again, if I have, but the smallest shape has to have three sides. The sum of the interior angles are going to be 180 degrees. If it's four sides, it becomes 360. If it's five sides, 540. If it's six sides, add 180 to it. Mental math, that should be 720. Seven sides, it should be 900. And let's go far as eight sides, it should be 1080. And as I wrote before, every single time I increase the number of sides, I add 180. Doesn't that look familiar? It's sort of like our slope. It's sort of like our first difference. It's sort of like our rate of change. What does that mean? Y is equal to m times x. What is it? Y is equal to my rate of change times the number of sides. So this would be the sum, right? But guess what? N does not start at 3. If n was a 3, is there a way to pretend that is actually 1? Well, that's where the n minus 2 comes in. It's actually, if the number of sides is a 3, I subtract by 2 so that the bracket turns into a 1. And so our first value for the y side is 180. And that's all it is. This equation right here is going to be applied in a variety of different ways, in a variety of different questions that you will find in the textbook. Give that a shot. Again, this is a bit of a trial video. Yeah, I'm not sure how effective this kind of style is. There will be some handouts moving forward. And if you are watching this video, I am hoping you've given yourself a shot, given yourself a chance in studying 7.3 as well as 7.4. Okay? That responsibility, that expectation is going to be placed on your shoulders, so I hope you can handle it. If I feel that this is a good way to go, or in collaborating with other teachers, our lessons will probably start from 7.5. So please use this week to at least finish all of the work I assigned to you last week up to 7.4. Okay? I really do hope to see you soon. I miss you all. Stay safe and take care. Bye.